So today we're going to do something simple called trapezium rule. It's a technique used to find the integrals, right? So for example, let's say I hold on, right? Let's say I ask you to integrate for me. Let's say you have to integrate some function, right? Let's say it's x squared between 0 and 5, right? You could obviously work that out, right? You could integrate it and then plug in 0 and 5. But there's a rule called trapezium rule that could be used to estimate it, right? Let's say you had something like that, and you wanted to find the area between, the integral between 0 and 5 of a function x squared. Then in order for you to actually find that integral, is just like finding the area. But if you look closely, this is a curve, it's not a straight line. So it'll be difficult for us to find the exact area. So what they did is they broke up the big shape here into small trapezia, right? So they broke it up into equal trapezia. So this is one here, right? Nice equal trapeziums, right? Right. Of course, it wouldn't be exact because there's little pieces. Hold on, Let me do it a little bit nicer. Right. Let's break it up into how much? About 5 equal 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. So what they did is they broke it up into 5 trapezia. So one will look like this. Next one like this. Last one might look like that. What you would recognize that little piece is missing. So it's not the exact area. So the answer you get here will be an approximation when you use the trapezium technique, right? And the principle behind the trapezium technique is basically, if you have 5 trapezium, they multiply 5 by the area of 1, right? So you just find the area of 1, half the sum of the parallel sides, right, multiplied by the height. Right? That's the concept behind the trapezium rule, right? And the trapezium rule, there's a nice little formula, right? I'll show you. I can always show you the proof, right? But I'm gonna show you how to use it for today, right? And the proof is basically based on adding up all the trapezia. Hold on, right? And the formula now for trapezium rule looks like this. Right, the good thing is you don't really have to memorize it because it's come in your formula sheet, right? But the integral between a and b of any function with respect to x, right, with respect to x, right, I think is have h on 2 open brackets. You find an f of x0. I'll show you where's x0 plus, that's a 0, plus f of the last value. I just want to write this a little bit better. Lord. Right, f0 plus a half of everything else. Right, that'll be f1 plus x2 all the way until x to the n minus 1, right? So that's technically what your formula will look like. Okay, what do all those f's and all those things mean, right? It's simply this. I'm gonna give you a nice example. I'll use one from a textbook, so we don't have to work out anything in the initial stage, right? Right, so I'm going to show you how to use that formula there to find the integral. So suppose we had to find the integral between 0 and 1 of this function here, 1 over 1 plus x squared dot dx, right? And I want you to find the integral using, right? Let's use using 5. They want to use 5 trapezium. So we're going to subdivide the area into 5 equal trapezium. That's the area, right? One thing I forgot to show you is how to find h. H is b minus a over n, right? N is like a number trapezium. Okay, so let's set it up. First thing first, what is h? H is 1 minus 0, b minus a, right? B minus a all over 1/5 trapezium, so that's 5. So h is 1/5. Okay, what's the purpose of h? The purpose of h is to allow us to break this up evenly, right? 0, 1, 2, 3, 4, 5, right? So this is 0, and each giving you an idea of the increments, right? So it equals, so here's 1/5 plus the next 1/5 plus the next 1/5 plus the next 1/5 plus 1. Okay, so that gives you an idea of how we break in a trapezium to get 5 equal trapezium. And they are always equal, right? Are you with me so far? You all there so far? Come on, just 10 all you, so she paying attention. Nice, Chelsea, good. Shivani, good, Koi. Nice, good. Just to make sure they're paying attention. Good. What do these values represent? Well, this value here represents x0 in the formula. This is x1. This is x2 in the formula. This is x3. This is x4. This is x5. Right? Those are the things in the formula. Now, we need to be able to get all the f of x values. Nice and easy. We know the x values, right? So that's 0, 1/5. Here what? And wouldn't fit it as a fraction. I'm going to put it as a decimal, right? Just to help me out a little bit with space. 0.2, 0.4, 0.6, 0.8, and 1. And then this is 0.10. Right. How do we find f of x now? Well, all I have to do is to put 0 in f of x, and I'll get 1. Then put 0.2. So this is 1 over 1 plus 0.2 squared. And then you work it out, right? I don't have a calculator. I'm using a book. I'm using Bahal book here for this example, right? So I just using what he have. 0.96. I'm just rounding it off, right? That's three significant figures. 0.962, 0.862, 0.735, 0.61. Yeah, 0.61. And last one, 0.5. Oh Lord. And then it's going, right? So now that you have all the values, all we have to do now is we go to the trapezium rule formula, right? Right? We go to the trapezium rule formula and we just plug in all the values. Right? So I plug in the t in one time. It will be h over 2. What's h? H is 0.2, right? 0.2 over 2 open brackets, the last value, right? Sorry, the first value, that'll be 1, and the last value, 0.5, right? And then we're going to add that to 2 of the third. We know them two damn team draw, and Fatima them like the draw too. And sickening my. Thank God me if I ain't going I get some mad. And 0.96. So I put in already put in fx0, fx5. Now here I'll put the other remaining y values 0.962, 0.862, 0.735, and 0.61. And that's it. Plug in the value, and the integral should be, I cannot see, the integral should be 0.784. So if you do that integral the long way, that's where you should get 0.784. By the way, what is the integral of 1 over 1 plus x squared? Anybody remember? What's the integral of 1 over 1 plus x squared? Nobody remember? Not even one person remember. Shivani, remember? What's the integral of 1 over 1 plus x squared? No. All right. That's all the homework. I'll look for that. Look for it. I'm not telling you. Me not saying nothing. Not how to look for that. Tan inverse. Good job, Chelsea. Thank you, Chelsea. All right, nice. Are you okay with that? So all we have to do, let me tell you, to be honest, the hardest thing here is to figure out what n. As the hardest thing in questions. Both of the tests tell you how about your PZA, what that you to figure out. Any questions, Olia? Right, and here's all we're doing today. Right, we're just doing trapezium rule, and that brings us to the end of module 1. Right? So let's do a few now. You won't see this so much in the past papers, probably like 3 or 4 in the past papers. But it's the last thing. Right, so we'll do a little summary of module 1, and then we'll do, as I told you, I do module 3 next. Right, because module 3 has integration and differentiation in it. All right, copy it down. Let's try one now, please. right? Sometimes in these questions, it's like how I asked you to actually hear what to do from them, because sometimes they come like this. Sometimes they also come where they ask you now to compare to the actual value. So find the actual value here from her. I want you to find the actual value. Work it out for me now, please. Remember, Chelsea told us that the integral of 1 on 1 plus x squared tan inverse, right? So it's tan inverse between 1 and 0. How much you all got? Remember to work in radians, right? Right. Chelsea got 0.785. Okay, nice. All right, so let's try one now. All right, so we see that the estimate was pretty close to the actual value, right? So for this one here, I want you to do it both ways, Summer. I would like you to integrate between 2 and 0 of x by the square root of x squared plus 1. Right, do it both ways, Summer. Right, I want to get the actual value, and I would like it to use trapezium rule with 8. That's supposed to be width, right? Width 8 equal trapezium. All right, I give it 8, right? Just a practice. Just want to give you a practice, right? Actually, should I do 8 or 4? Do the 8, right? Do the 8. Right? You can do 4, but the less you do, the less precise the value will be. Less accurate, I should say. Right? Go ahead. Both ways, right? I'd work it out both ways. How are you going to integrate that normally? What technique are you going to use to integrate that normally? For sure. All right, so let's attempt with trapezium rule part first. First thing first is to get the H. For those who now log in, this is the formula we're using, right? Real simple. Is to find trapezium rule. So just screenshot this, and we're using this to find the trapezium, to find the integral. I just screenshot that, and I'll do this example here. Right, I was asking, oh shucks, what happened there? Right, I was asking before we went on commercial break there, was it technique that we're using? Was it technique besides trapezium rule to integrate this? Anybody knows? How do you integrate this normal way? Very good, Koi. Integration by substitution. Okay. Integration by substitution, right? All right. So first thing first is to get H. H is B minus A all over N, which is a quarter or 0.25, right? Right, in order for us to use the formula, we have to get all the X values and then get the corresponding Y values, right? So the first X value will be 0. Remember, you're starting from 0, and you're just going to keep adding on H. So that'll be 0.25, 0.5, 0.75, 0.1. That's 1, 2, 3, 4, 5 was 0. Wait, that's wrong. I meant 1.0. 1.0, 1.25, 1.50, 1.75, and 2.0. Right? We have our H trapezia there. And then all we have to do is plug in 0 here, plug in 0.25 here, plug in 0.5, plug in 0.75. That's all we're doing. Right? When you plug in 0, you're getting 0, obviously, right? When you plug in 0.25, what you all got? I have 0.257, 0.256. Sorry, 0.258, right? Round it off to 3 significant figures, right? Then plug in 0.5, and you'll get 0.55902. Then plug in 0.75. It have 0.938. Everybody okay with how again those values? Jada? Benicia? You all okay with how I got those values? Yeah? Okay. Then I plug in 1. Right? When you plug in 1, you're getting 1.414. Plug in 1.25, you'll get 2.001. 1.5, that's 2.704. 1.75, 3.527, and last one, 4.472. H is this here. H is the, oh sorry, that's N. H is this formula. B minus A over N. Right? That's H. So you keep adding h to the lowest x value, which is 0, until you reach the largest x value. And then we're using the formula. So the formula now to get the integral, of 20x by x squared plus 1, right? To get that integral, remember, is h on 2. Where is h? 0.25 on 2, open brackets, the first value and the last value, plus 2 by all the other values. 0.258 plus 0.559 plus 0.938 until the second to last value, 3.527. And you plug it in a calculator. As I said, I got this on the textbook, yeah? So that's why I have the value already. And it's 3.409. Okay? That's the value. But I also want you to do it the next way. So you're using substitution. So you could let u equal to x squared plus 1, right? And you will get du dx to be equal to 2x. Therefore, dx is equal to 2u on 2x. So you will end up with, and here we could do, right? We could change the limits one time. When x is 2, u is equal to 5. 2 squared plus 1, right? When x is 0, u is 1. So I'm changing the limits one time. The limits are 5, 1 of x by the square root of u dot du on 2x. So the x will cancel, and you'll get the integral between 5 and 1 of a half by u to the half dot du. So that'll be a half by, add 1 to the power, you'll get 3 on 2, divide by the new power, and then plug in 5 on 1. And you work out that. Plug in 5, plug in 1, and you should have the answer. Okay, remember, I use 5 and 1 because I changed the limits. And according to the book, they have 3.393. Right? And as I said, that's the main problem. The main problem is figuring out how much trapezium to use. Right? Right. What you all understand, everybody okay with this? The principle behind, I know some of you all didn't work it out because I went fast, right? Did you all understand the principle behind it?
Yeah, sir. I think so.
Yeah. Okay. So that's one little thing I want to ask you, right? Suppose the question said, instead of 8 equal trapezia, right? The question said 9 intervals, 9 subintervals. So find the approximate value using trapezium rule, but they want you to use 9 subintervals. What do you all think that means?
N is equal to 9.
N is equal to 9. Close to it. Close to it. Wait. What I said 9? Yeah. Sorry, I thought I said 8. Yeah. So if they said 9 subintervals, right? You use N as 9. So all you have to do really is try to figure out. All you have to do is try to figure out what those values mean, right? I remember seeing this once in an old paper. They said to use using 9 ordinates. What do you all think that means? 9 ordinates, right? In case you never heard the term ordinates, ordinates simply mean this is 1 ordinate, this is 2, this is 3. So if they say 9 ordinates, you'll recognize that 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ordinates mean n is equal to 8. Okay? So if you see they use the term ordinates, then ordinates mean the number of values for x or y. And the number for n will be 1 minus that. Okay? So that is how you use trapezium rule. Right? And that's it. That's the end of module 1. Right? I'll give you one more to do, and that's it. I'll give you like 3 intervals or 4 intervals, right? All right, but that's the principle behind doing this, right? All right, so let's just try one. Find the integral between 1 and minus 1 of the square root of ln open brackets 3 plus x. All right. Right, obviously use trapezium rule with 5 ordinates. Right? What does 5 ordinates mean again? N is how much? Right? Good job. N is 4. Right? Go right ahead and do this real fast, Mana, please. Right? So just 5 ordinates you're working with. Work it out and give your answer to the usual 3 significant figures, right? I do have the values for this one, so work it out because I'll need your help, right? Go ahead, do this, please. right? Anybody can help me out there? What you got for when x is minus 1? Square root of ln 2, right? 0.833. What you got for your next one? .957. Nice. What's the next one? .048. Good. Next one. 1.119. And last one. Good. And that's it. All you have to do now is just use the formula. So the integral for 1 to minus 1 of the square root of ln 3 plus x.
So it's 1.177.
Is 1.177. Okay. Right. So same thing, formula h over n. Sorry, h over 2 plus the first y value plus the last y value plus 2 by all the other values. You know, it's a good exercise for you for homework. Prove the formula. See if we can prove the formula. 2 by 0.957 plus 1.048 plus 1.119. Right? How much y'all got there? .0645. 2.0645. Anybody else got a? Okay.
Yes, sir.
Okay. Nice. And I think you might be able to put it in the calculator. Put it in the calculator now and see if we could get the exact value from the calculator.
Yes, I get that exact value from the calculator.
Okay. No, you put in this in the calculator.
Oh, that, okay.
Yeah, put that from the calculator technically use trapezium rule to work it out. That's why they can't give you an integral. They can't give you a value. They can show you the integral, but they can give you the value if it has limits. Because technically the calculator using this with a lot of intervals. So put that whole thing in the calculator between minus 1
2.0688.
Okay. All right, nice. Not bad. Right? You could work out the difference between the values too. All right, so nice. That is your trapezium rule. Right? I'm not doing anything else today. Right? So all we had to do is go over this next week. I will make a sweep through, make a little summary on module 1, and that will take us into something in module 3 called differential equations. Well, you all might remember solving equations like this. I think in unit 1, we did separation of variables. Right? So we're going to learn to solve things like this. Right? We're going to do first order and second order, and then wrap up with matrices and probability. Probably the hardest thing in module 3, probability. Some people do like probability.